dapat dipengaruhi anomali iklim global, salah satunya La Nina. La Nina adalah fenomena mendinginnya suhu air laut di Samudra Pasifik bagian timur dan tengah. La Nina mengakibatkan penguatan angin pasat ke Samudra Pasifik bagian barat yang lebih hangat. Angin pasat adalah angin yang bertiup dari daerah subtropis menuju ke ekuator. Saat La Nina, suhu permukaan laut di Samudra Pasifik bagian barat termasuk Indonesia lebih hangat dibanding normalnya. Air di atmosfer Indonesia lebih banyak sehingga meningkatkan pembentukan awan hujan yang menyebar meningkat di wilayah Indonesia.
Menjelang akhir tahun, bencana
kapan prediksi hujan lebat akan berlangsung?
BMKG hadir menyampaikan informasi cuaca serta iklim di darat, laut, dan udara. Informasi kami berbasis data mendukung keselamatan dan kesejahteraan masyarakat Indonesia. Waspada cuaca, peduli iklim, selamatkan laut.
School of Meteorology, Climatology, and Geophysics is a professional official education institution in the field of meteorology, climatology, geophysics, and instrumentation, under sponsored program of meteorological, climatological, and geophysical agency. And geophysics trains senior high school graduates to become high detected analysts to improve the quality of services in meteorology, climatology, and geophysics. Academy of Meteorology and Geophysics, or AMG, was established in 1955 at Bandung Institute of Technology, or ITB, which then moved to Jakarta 1960. AMG became Education and Training Center for Meteorology and Geophysics in 1978 under Organizational Structure of Education and Training Agency in Ministry of Transportation. Later on, in 2000, Training Center for Meteorology and Geophysics renamed again as Academy of Meteorology and Geophysics, and its campus moved to Perhubungan 1 Street of Pondok Betung, Bintaro, South Tangerang. In 2004, AMG was under Organizational Structure of Meteorological and Geophysical Agency, or BMK, as a governmental agency. In 2008, BMK became Meteorological, Climatological, and Geophysical Agency, or BMKG. But the organization remained unchanged. In 2014, AMG officially became STMKG, or School of Meteorology, Climatology, and Geophysics. STMKG held higher education in meteorology, climatology, geophysics, and instrumentation for 4 years.
Success is determined by the quality of human resources. STMKG has the vision and mission of contributing to build human resources in a sustainable manner. Through education and training human resources in the fields of meteorology, climatology, geophysics, and instrumentation. Mission of School of Meteorology, Climatology, and Geophysics are: first, preparing cadets to become member society of meteorology and geophysics who have professional skills in the fields meteorology, climatology, geophysics, and instrumentation. Second, spread knowledge in the field of meteorology, climatology, geophysics, and instrumentation seeking to improve the implementation of public welfare and enrich the national culture. The third, carry out research that aims to develop the application of science in the field of meteorology, climatology, geophysics, and instrumentation.
Provide four departments that are Department of Meteorology, Department of Climatology, Department of Geophysics, and Department of Instrumentation. Education is organized within 8 semesters or 4 years. Meteorology is a branch of science that studies the atmosphere and its phenomena. Cadets majoring in meteorology are demanded to be able to conduct the analysis, data processing, and providing services in the field of aeronautical meteorology, maritime meteorology, and meteorology for public services. Climatology is a branch of science that studies long-term weather conditions, or often called climate. Cadets majoring in climatology demanded to be able to conduct the analysis, data processing, and providing services in the field of climatology and air quality, and also become a reliable expert climatologist which has global conception. Geophysics is a branch of science that studies about the physical process that occur on Earth. Department of Geophysics generates reliable cadets in studying earthquake, earth magnets, air, electricities, timing marks, and other natural phenomena through physical approach. Cadets majoring in geophysics is required to observe elements of geophysics, geophysical processing, and analysis, and also skilled in the practice of geophysical instruments. Instrumentation is a branch of science that studies on equipment or instrument used by BMKG departments. Cadets majoring in instrumentation is required to perform an installation's repair, calibration, and maintenance to the meteorological, air quality, and geophysical equipment, and also maintenance communication network and computers. To support the teaching and learning activities, STMKG has several facilities including Meteorology Laboratory, Climatology Laboratory, Air Quality Laboratory, Geophysics Laboratory, Instrumentation Laboratory, Computer Laboratory, Language Laboratory, Physics Laboratory, Library, Polyclinic, Fitness Center, and Canteen. In addition to learning about the science of academy, cadets also learn about the social community, culture, and shaping the character through spiritual activities, which are accompanied by activities that increase the potential talents and interests such as marching band, pasus, karate, science, photography, indoor soccer.
Indonesia merupakan negara kepulauan yang berada di garis khatulistiwa, terletak di antara 3 lempeng aktif, 2 benua, dan 2 samudra, sehingga menjadikan Indonesia sebagai negara maritim dan agraris. Tidak hanya memberi keindahan, Indonesia kaya akan sumber daya alam.
Ladies and gentlemen, we are about to begin the ceremony. The Honorable Professor Bambang Permadi Sumantri Brojonegoro, PhD, as the Minister of Research and Technology. The Honorable Professor Insinyur Dwi Korita Karnawati, MSc, PhD, as the Head of the Agency for Meteorology, Climatology, and Geophysics. The Honorable Professor Dr. Arif Satria, MSc, as Director of IPB University. The Honorable Professor Dr. Thomas Jamaludi, as the Head of National Institute of Aeronautics and Space. The Honorable Dr. Kunio Yoneyama, as the Director of Department of Coupled Ocean Atmospheric Land Processes Research, Japan Agent and Technology, JAMSTEC. The eminent speakers, guests, participants, ladies and gentlemen. Good afternoon and welcome to the second International Conference on Tropical Meteorology and Atmospheric Sciences. This conference aims to establish international scholars and academic community in tropical of the tropics, especially over the maritime continent region. The conference is co-organized by Center of Research and Development of the Agency for Meteorology, Climatology, and Geophysics, or BMKG, the Geophysics Meteorology Department of IPB University, and the College of Meteorology, Climatology, and Geophysics First World Meteorological Day today, 23rd March 2021. Due to the global pandemic impact, the conference that was originally planned to be held in Jakarta has to adapt to the new normal and is held virtually instead. Ladies and gentlemen, our next agenda is singing Tampilan.
Indonesia
Ladies and gentlemen, let us start this conference with a prayer, hoping for the success of this conference and that everything will run well without any obstacle. Pray based on individual belief. Praying, begin. Finish. Ladies and gentlemen, we are now going to listen to the organizing committee report that will be delivered by the Director of Research and Development Center of BMKG, Dr. Nelly Floridariama. I would like to invite Dr. Nelly Floridariama to deliver the report.
Good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. It is my pleasure to welcome Honorable Professor Bambang Permadi Brojonegoro, Minister of Technology and Head of National Research and Innovation Agency, Republic of Indonesia. Professor Insinyur Dwi Master of Science PhD, Head of the Indonesian Agency for Meteorology, Climatology, and Geophysics. Professor Dr. Arif Satria, Rector of IPB University. Professor Dr. Thomas Jamaluddin, Head of National Institute of Aeronautics and Space, LAPAN. Dr. Kunio Yoneyama, Director of the Department of Coupled Ocean Atmospheric and Process Research, Japan Agency for Marine Earth Science and Technology, Japan. The eminent speakers and participants from all over the world for the second International Conference on Tropical Meteorology and Atmospheric Science 2021. Distinguished ladies and gentlemen, first of all, let's thank God given health to all of us so that we can hear for second International Conference on Tropical Meteorology and Atmospheric Science ICTMAS event this afternoon. ICTMAS is an international scientific forum where researchers, academia, and students from various institutions and universities from several countries can share knowledge, experiences, new finding research, and works in the field of tropical meteorology and atmospheric science together. On behalf of the committee and all participants, we want to give our highly appreciation to Professor Dr. Dwi Korita Karnawati, Head of BMKG, and Professor Arif Satria, Rector of IPB University, for the support to this event and for joining us today to give welcoming and opening speech. We are also very proud to have Professor Bambang Permadi Sumantri Bojonegoro, Minister of Research and Technology, Head of National Research and Innovation Agency, Republic of Indonesia, to give the keynote speaker, following by Dr. Kunio Yoneyama from Jamstek, Japan, and Professor Dr. Thomas Jamaluddin, the head of LAPAN. Ladies and gentlemen, this second ICTMAS will be held in the next 3 days, from 23rd to 25th of March 2021. This event is co-organized by Center for Research and Development of Indonesian Agency for Meteorology, Climatology and Geophysics, Geophysics Meteorology Department of IPB University, and College of Meteorology, Climatology and Geophysics. IC was also supported by various national and international organizations. Ladies and gentlemen, originally the conference was planned to be held in 2020. However, due to COVID-19 pandemic, the conference will start from today virtually for the first time. This event also coincides with the celebration of World Meteorological Day. The theme of the celebration of World Meteorological Day this year is "The Ocean, Our Climate and Weather." in conjunction with the launch of the United Nations Decade of Ocean Science for Sustainable Development. Ladies and gentlemen, the ICTMAS 2021 has 5 main topics: basic science, observation, modeling, services, and extreme events. Related to these topics, the committee of the ICTMAS has received in total of 311 abstracts from all participants. And finally, we have the remaining 220 abstracts were selected to be presented in this conference via oral and poster presentation. By the topics, there are 22 abstracts for basic science, 44 abstracts for extreme events, 78 abstracts for modeling, 18 abstracts for services, and 58 abstracts for observation. The abstract came from Indonesian researchers and students, and also participants from other countries like Belgium, Netherlands, UK, China, Japan, Australia, and United States. We have also found that the participation from male and female scientists are almost equal. The number of participants have reached more than 750 and still counting. The ICTMAS 2021 also will be attended by 16 invited speakers. They come from BMKG, LAPAN, IPB University, University of East Anglia, PML NOAA, Rice University, Texas A&M University, Jamstack, UKMO, and other universities also. Ladies and gentlemen, the complete full papers will be selected and proposed for publication in a global index and reputable proceedings. IOP Conference Series Earth and Environmental Science, Jurnal Meteorologi dan Geofisika, and Agromet. We will also announce the best oral and poster presenters at the end of the conference. Ladies and gentlemen, we do hope this second ICTMAS conference can run smoothly and all participants can have a fruitful discussion and sharing experiences, and also stay healthy during the event. And finally, we want to express our deepest gratitude to all of those who have been contributed to this event so that this second ICTMAS 2021 can be well organized. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Nelly, for delivering the report. Ladies and gentlemen, we are now going to listen to the welcoming speech that will be delivered by the Rector of IPB University, Professor Arif Satria. Ladies and gentlemen, please welcome Professor Arif Satria.
The Honorable Minister of Research and Technology, Republic of Indonesia, Professor Bambang Sumantri Brojonegoro, Head of the Agency for Meteorology, Climatology, and Geophysics, Professor Dwi Korita Karnawati, PhD, Head of National Institute of Aeronautics and Space of Indonesia, Professor Dr. Thomas Jamaludin, Director of Department of Coupled Ocean Atmospheric Land Process Research, Jamstack, Dr. Kunio Yoniyama, Dean, Director, Head of Research Center, Moderator, Speaker, Professors, Researchers, and all participants. Good afternoon, and Assalamualaikum warahmatullahi wabarakatuh. It is my great honor and to greet all of you and to particularly extend our warm welcome, especially to distinguished invited speakers and all participants in the second International Conference of Tropical Meteorology and Atmosphere Science, ICTMAS. The conference is organized by the Center for Research and Development of Indonesian Agency for Meteorology and Climatology and Geophysics, Department of Geophysics, Meteorology, IB University, and College of Meteorology, Climatology, and Geophysics. Ladies and gentlemen, ICTMAS 2021 will be one of the most interesting conference in 2021, covering all disciplines of the tropical meteorology and atmospheric science. The meteorology and atmospheric science has a critical role to the advance of fundamental understanding, the identification of environmental threats, as well as the prediction of weather and climate change. In the current era, we are dealing with the huge global problems such as climate crisis. No corner of the globe is immune from the devastating consequences of climate change. Rising temperatures are fueling environmental degradation, natural disasters, weather extremes, food and water insecurity, economic disruption, conflict, and terrorism. Climate crisis impacts everyone's food and water security, and it is also has a direct cause of biodistribution, which limits the amount of carbon the Earth is able to contain. To some extent, the effects of climate crisis heighten competition for resources such as land, food, and water, fueling socioeconomic tensions and increasingly often leading to mass displacement. These problems are best addressed through international cooperation. It is clear that global action is needed to create a more sustainable future. Ladies and gentlemen, given its primary role as knowledge producer, higher education can serve as a powerful means to help create a more sustainable future. This conference is the best moment to collaborate and found inspiration to deal with the global climate disaster, as well as exchange experiences and sharing good ideas in field of tropical meteorology and atmospheric science. I believe that the ICTMAS can strengthen international collaboration in research and application, especially on tropical meteorology and atmospheric science. On behalf of IBB University, I'd like to express my sincere gratitude to all stakeholders, especially for the organization committee, who have been working hard to organize and review paper for this conference. Also, we'd like to express our gratitude to moderator and invited speakers and all participants, last but not least, for your health and fruitful experience. I hope this conference will be successful and enjoyable event. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Indonesia terletak di antara dua samudra besar yang dapat dipengaruhi anomali iklim global, salah satunya La Nina. La Nina adalah fenomena mendinginnya suhu air laut di Samudra Pasifik bagian timur dan tengah. La Nina mengakibatkan penguatan angin pasat ke Samudra Pasifik bagian barat yang lebih hangat. Angin pasat adalah angin yang bertiup dari daerah subtropis menuju ke ekuator. Saat La Nina, suhu permukaan laut di Samudra Pasifik bagian barat termasuk Indonesia lebih hangat dibanding normalnya. Hal itu menjadikan uap air di atmosfer Indonesia lebih banyak sehingga meningkatkan pembentukan awan hujan yang menyebabkan curah hujan dan potensi bencana meningkat di wilayah Indonesia.
Menjelang akhir tahun, bencana
Kapan prediksi hujan lebat akan berlangsung? Saya akan beritahu.
BMKG hadir menyampaikan informasi cuaca serta iklim di darat, laut, dan udara. Informasi kami berbasis data observasi yang dipublikasikan untuk mendukung keselamatan dan kesejahteraan masyarakat Indonesia. Waspada cuaca, peduli iklim, selamatkan laut. Selamat Hari Meteorologi Dunia ke-71.
Basic sciences have had a very important role in the development of science and technology throughout human civilization. The Bogor Agricultural University now called IPB University, pioneered the establishment of the Faculty of Mathematics and Natural Sciences as a foundation for the application of sciences in IPB and as an effort to develop relevant science and technology to utilize and manage resources for people's welfare, mainly related to agriculture, marine, and tropical biosciences.
Visi kami menjadi fakultas bidang MIPA yang terkemuka di Indonesia dan bertaraf internasional.
The Faculty of Mathematics and Natural Sciences, known as FMIPA IPB, is located at the Dramaga campus, Bogor Agricultural University. This faculty has 8 departments from various different disciplines. This faculty organizes educational programs from bachelor, master's, and doctoral levels under the guidance of a competent teaching staff according to their respective expertise. Various collaborations both at national and international levels in the framework of research, human resources development, and community service are held regularly and periodically as a form of realization of the 3 pillars of higher education mandates.
Science for community, mission, and prosperity.
FMIPA IPB is more than basic science.
Thank you, Professor Arif Satria, for the speech. Ladies and gentlemen, we are now going to listen to the opening speech that will be delivered by the head of BMKG, Professor Insinyur Dwi Korita Karnawati, MSc PhD. Ladies and gentlemen, please welcome Professor Insinyur Dwi Korita Karnawati. Apologize everyone, so we have to wait for the next several minutes before we are going to listen to the opening speech. So for now, please watch this video of our.
Indonesia merupakan negara kepulauan yang berada di garis khatulistiwa, terletak di antara 3 lempeng aktif, 2 benua, dan 2 samudra, sehingga menjadikan Indonesia sebagai negara maritim dan agraris. Tidak hanya memberi keindahan, Indonesia kaya akan sumber daya alam yang memberi kesejahteraan kepada masyarakat luas. Namun di balik keindahan itu tersimpan potensi bencana. Kondisi alam itulah yang menjadikan peran BMKG sangat penting. Penduduk yang padat, pembangunan infrastruktur, perkembangan industri, dan tingginya penggunaan alat transportasi sangat berkontribusi terhadap cuaca, iklim, dan kualitas udara. BMKG merupakan lembaga resmi yang menangani masalah cuaca, iklim, kualitas udara, gempa bumi, dan tsunami. Sehingga BMKG sangat erat kaitannya dengan keseharian kehidupan masyarakat di Indonesia. BMKG memiliki 186 unit pelaksana teknis pengamatan yang tersebar di seluruh Nusantara. Kami senantiasa memberikan informasi cuaca untuk penerbangan, maritim, dan pariwisata. Informasi iklim untuk pertanian dan ketahanan pangan. Informasi kualitas udara untuk mengantisipasi perubahan iklim. Informasi gempa bumi dan tsunami, serta informasi terkait hilal dan penanda perubahan waktu. BMKG senantiasa menyajikan informasi secara rutin terkait cuaca, iklim, kualitas udara, gempa bumi, dan tsunami. BMKG memiliki stasiun pengamatan meteorologi, klimatologi, geofisika, dan Global Atmosphere Watch yang tersebar di seluruh Nusantara. BMKG memiliki 120 stasiun meteorologi yang berguna untuk mendukung kelancaran transportasi udara, laut, dan darat. Setiap harinya stasiun meteorologi mengambil data secara manual dari taman alat dan radar cuaca. Data tersebut lalu diolah sehingga menghasilkan produk layanan informasi prediksi cuaca yang bermanfaat untuk kelancaran transportasi, pertambangan, pariwisata, olahraga, dan kesehatan. BMKG memiliki 27 stasiun klimatologi. Setiap harinya stasiun klimatologi mengambil data dari taman alat. Data tersebut lalu diolah untuk menjadi dasar prediksi cuaca dalam jangka waktu tertentu. BMKG memiliki 31 stasiun geofisika. Setiap harinya stasiun geofisika mengambil data dan diolah sehingga menghasilkan sistem peringatan dini gempa bumi dan sistem peringatan dini tsunami. BMKG memiliki 3 stasiun pemantau atmosfer atau Global Atmosphere Watch. Stasiun GAW terletak di Bukit Kototabang, Sumatera Barat, Bariri, Sulawesi Tengah, dan Sorong, Papua Barat. Global Atmosphere Watch bertujuan untuk mengawasi efek emisi gas rumah kaca dan parameter yang berada di atmosfer bumi.
School of Meteorology, Climatology, and Geophysics is a professional official education institution in the field of meteorology, climatology, geophysics, and instrumentation, under sponsored program of Meteorological, Climatological, and Geophysical Agency. School of Meteorology, Climatology, and Geophysics trains senior high school graduates to become high detective analysts to improve the quality of services in meteorology, climatology, and geophysics. Academy of Meteorology and Geophysics, or AMG, was established in 1955 at Bandung Institute of Technology, or ITB, which then moved to Jakarta 1960. AMG became Education and Training Center for Meteorology and Geophysics in 1978 under organizational structure of Education and Training Agency in Ministry of Transportation. Later on in 2000, Training Center for Meteorology and Geophysics renamed again as Academy of Meteorology and Geophysics, and its campus moved to Perhubungan 1 Street of Pondok Betung, Bintaro, South Tangerang. Institutional structure of Meteorological and Geophysical Agency, or BMK, as a governmental agency. In 2008, BMK became Meteorological, Climatological, and Geophysical Agency, or BMKG. But the organization and management
Thank you. We would like to welcome Dr. Hamam Riza, the head of the Agency for the Assessment and Application of Technology. Welcome to the ceremony, Dr. Hamam Riza. So now, let us watch our video that will be uploaded by the WMO tonight in the occasion of the World Meteorological Day celebration in WMO headquarters.
Maritime country in the world, we are aware of the importance of our ocean in influencing the world's weather and climate, especially the influence of the Indonesia through flow connected between the Indian and Pacific Ocean to the weather and climate states in the world. Indonesia, through the Agency for Meteorology, Climatology, and Geophysics, BMKG, is strongly committed to contribute to the safety of human activities and community welfare by continuously educating people on the importance of ocean weather climate literacy and sustaining our observation and keep strengthening our provision of the accurate maritime weather and climate information, as well as early warning of the coastal disaster information, such as storm surge, tsunami, and sea level rise, to the community in Indonesia and in the region. World Meteorological Day of 2021. Let's strengthen our partnership for the better ocean weather climate information. Being the largest maritime country in the world, we are aware of the importance of our ocean in influencing the world's weather and climate, especially the influence of the Indonesia through flow connected between the Indian and Pacific Ocean to the weather and climate states in the world. Indonesia, through the Agency for Meteorology, Climatology and Geophysics, BMKG, is strongly committed to contribute to the safety of human activities and community welfare by continuously educating people on the importance of ocean weather climate literacy and sustaining our observation and keep strengthening our provision of the accurate maritime weather and climate information, as well as early warning of the coastal disaster information, such as storm surge, tsunami, and sea level rise, to the community in Indonesia and in the region.
Nama lengkap kalau itu udah tahu. Memang sopo.
World Meteorological Day of 2021. Let's strengthen our partnership for the better ocean weather climate information.
Agency for Meteorology, Climatology, and Geophysics. Welcome, Professor Dwi Korita Karnawati. Ladies and gentlemen, We are now going to listen to the opening speech that will be delivered by the head of BMKG, Professor.
Thank you very much for the organizer. And I would like again to thank you for the opportunity to speak to this distinguished audience. It is my pleasure to welcome Honorable Professor Bambang Permadi Sumantri Brojonegoro, PhD, as the Minister of Research and Technology, as well as the head of National Research and Innovation Agency, Indonesia. Also to Professor Dr. Arif Satria as PMSE, Rector of Bogor Agriculture as the Rector of Bogor Agricultural Institute, IPB Indonesia. Then Professor Dr. Thomas Jamaluddin, the head of National Institute of Aeronautics and Space, Lapan, Indonesia. Thanks also directed to the Honorable Dr. Hamam Riza as the head of the Agency of Technology Development and Assessment, BPPT, and Dr. Kunio Yoneyama as the Director of Department of Coupled Ocean Atmospheric Land Processes Research, Japan Agency for Marine Earth Science and Technology, JAMSTEC, Japan. Then also the eminent speakers and participants from all over the world for the second international conference on tropical meteorology and atmospheric sciences 2021. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good morning or may also good afternoon. As you are all aware, Indonesia Maritime Continent, IMC, is a unique mixture of land and ocean straddling the equator between the Indian and Pacific Oceans. The IMC is the largest archipelago on the Earth, with surrounding waters amount approximately 70% of the total area under its jurisdictions. Sitting in the middle of the warmest body of water, known as the Indian and West Pacific Warm Pool, the IMC plays a pivotal role in the global weather-climate continuum. The country is also the center of the global multi-scale interaction involving global mean circulation and a wide range of phenomena, including strong convective activities encompassing various timescales such as diurnal, synoptic, intraseasonal, seasonal, interannual, decadal, and longer periods. Distinguished audience, the seasonal atmospheric condition of a maritime continent is mainly driven by the Asian-Australian monsoon. Precipitation over the maritime continent is highly influenced by the interseasonal Madden-Julian oscillation, MGO, and also highly affected by the El Niño Southern Oscillation and Indian Ocean Dipole Mode, IOD. At interannual timescale, the maritime continent is also crossed by Indonesian Through Flow ITF. As the artery connection between tropical Pacific and Indian Oceans and crucial link of the ocean general circulation that affects not only properties of these two oceans, but also global climate. This complex mixture of land and sea with various atmospheric and oceanic phenomena within those makes maritime continent as a unique, enigmatic, and challenging area for scientific endeavor on tropical meteorology and atmospheric sciences. In order to better understand the atmospheric and oceanic conditions and to improve the numerical weather prediction model skill, as well as to provide excellent weather service information over the maritime continent, the cycle of research to operations and operation to research processes need to be continuously and maintained. To enhance the capabilities of research to operation and operation to research for tropical atmospheric circulations, Indonesia through BMKG needs to establish partnerships with research institutions, including research and development of BMKG, universities, public sector, and international organizations. Enhance capabilities through R2O2R or research to operational and operational to research cycle would appear on products, models, observations, applications, and techniques. Various observation and research has been coordinated, campaigned, and conducted to better understand the atmospheric and oceanic condition over the tropics, especially the maritime continent. Since the International Winter Monsoon Experiment in 1978, Toga Core in 1993, Harimau that ended on 2010, and Cindy Dynamo in 2011, many scientific discoveries has been found to enrich the knowledge of atmospheric science on the tropics. The recent Year of Maritime Continent, YMC, during 2017 up to 2020, aimed to improve understanding and prediction local multi-scale variability of maritime continent weather climate system and its global impact through observations and modeling exercises was the state of art for such coordinated research on the tropics. As part of YMC program, BMKG have also involved in measurements and modeling of the Indonesian Through Flow International Experiment, or MINTI, the collaborative research among countries, including USA and Australia, start from 2020 to 2024, and along with LAPAN, have involved in weather and climate science for service partnerships, Southeast Asia, or WCSSPC, and Teramaris program in collaborative research with the United Kingdom from 2018 up to 2024. Ladies and gentlemen, the first international conference on tropical meteorology and atmospheric science had been held on 19th to 20th September 2018 in Bandung, West Java, Indonesia. Continuing the previous conference to share recent findings and knowledge on meteorology and atmospheric science of the tropics, especially over maritime continent, we proudly announced the second International Conference on Tropical Meteorology and Atmospheric Science 2021. Due to COVID-19 pandemic situation, this conference held virtually from 23rd up to 25th of March this year. Today's conference coincides with the celebration of the World Meteorological Day, which takes place every year on 23rd of March. The theme of the celebration of World Meteorological Day in 2021 is the ocean, our climate and weather, in conjunction with the launch of the United Nations Decade of the Ocean Science for Development. This topical reflect weather, climate, or water-related issues. World Meteorological Organization has stated when it comes to the weather and climate, most of us think only about what is happening in the atmosphere. However, if we ignore the ocean, we miss a big piece of the picture of the whole process of the weather and climate. Ladies and gentlemen, this second ICTMAS event is co-organized by Center for Research and Development of the Indonesian Agency for Meteorology, Climatology, and Geophysics, as well as the Department of Bogor Agricultural Institute and the College of Meteorology, Climatology, and Geophysics. ICTMAS 2021 is highly supported by Indonesian Ministry of Research and Technology through the Center of Excellence in Science and Technology program. The conference is also supported by the Indonesian National Institute of Aeronautics and Space, LAPAN, then also Agency for the Assessment and Application of Technology, BPPT, Bandung Institute of Technology, ITB, Indonesian Atmospheric Experts Association, A3I, Indonesian Association of Agricultural Meteorology, PERHIMPI, and Indonesian Researcher Union, HIMPENINDO. The conference is also supported internationally in collaboration with Japan Agency for Marine Science and Technology, JAMSTEC, and also the Year of the Maritime Continent, YMC program, Kyoto University, and other contributed institutions. The ICTMAS 2021 will bring scientists from all over the world to one meeting covering all disciplines of the tropical meteorology and atmospheric sciences and share recent knowledge on the related fields. The ICTMAS aims to provide a forum where scientists, especially early career scientists, can present their work and discuss their ideas with the experts in the fields of tropical meteorology and atmospheric sciences. The ICTMAS 2021 also aimed to strengthen international collaboration in research and education, especially on tropical meteorology and atmospheric. The topic of ICTMAS 2021 emphasized scientific research on tropical meteorology and chemistry, as well as the technological advancement on atmospheric observation and modeling, and the application of the sciences and technologies to humanity. We hope the ICTMAS 2021 aids in coalescing the community of interested researchers and practitioners around shared definitions, themes, best practices, and future research priorities. We are optimistic that the cross-disciplinary interactions of the second ICTMAS 2021 will foster contributions to produce new finding streams, inspiring future research, and supporting actionable science and risk calculations. Considering the nature emerging of broad applicability from the topic, we believe there is potential for highly visible and valuable research from this ICTMAS 2021. At the end, we plan to publish prospective article reviewed and to encourage media accounts that lead to greater research, practitioner, and public awareness. And finally, we hope this conference could promote and expand your research network further. Well, ladies and gentlemen, last but not least, by saying Bismillahirrahmanirrahim, we proud to declare the second international conference on tropical meteorology and atmospheric sciences 2021 is officially open. I hope the second ICTMAS 2021 virtual conference will run smoothly and productively, and all participants have a fruitful moment to exchange experiences and work together in the next 3 days. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Professor Insinyur Dwi Korita Karnawati, for opening the ceremony. Ladies and gentlemen, for your information, our opening ceremony this afternoon is attended by approximately 550 people through the Zoom platform, with the number of registered participants reached up to 908 people. We would like to inform you that the link to the participant attendee form can be accessed through the Zoom and YouTube chat, as this ceremony is now also being streamed through the YouTube platform. And don't forget that this conference will be held for 3 days, and registered participants can obtain certificate by the end of the session. In this ceremony, we also invited numerous speakers from many reputable institutions. So on the second day of the conference, we are going to have 2 sessions. The first session is the plenary session, and the second is the parallel session. In the plenary session, we are going to have a lot of speakers, such as Professor Takuji Waseda from the University of Tokyo, Mr. Yus Budiono, PhD from BPPT, Dr. Rahmat Hidayat from IPB University, Dr. Urip Haryoko from BMKG, Professor Adrian G. Matthew from University of East Anglia, Dr. Erma Yulihastin from LAPAN, Dr. Gert Jan Steenveld from Wageningen University, Dr. Paul Davis from UK Met Office. And then the parallel session will start from 15:30 to 17:30. On the third day of the conference, we are going to have 2 sessions as well. The plenary session will start from 7:45 to 9:45, and we are going to have a lot of speakers such as Dr. Sandro Lubis from Rice University, USA, Professor Scott Glenn from the State University of New Jersey, Professor Courtney Shoemaker from Texas A&M University, Song Yu Hong, PhD from NOAA Affiliate Scientist, Dr. Chidong Zhang from NOAA USA, Dr. Moteki Kosaku from Jamstec, Dr. Maurice Wichi from Jamstec, Dr. Wei Dongyu from Sun Yat-sen University, China. And next, we're going to have the parallel session from 10:20 to 12:20. Ladies and gentlemen, before going to the next session, let us watch this video first.
School of Meteorology, Climatology, and Geophysics is a professional official education institution in the field of meteorology, climatology, geophysics, and instrumentation, under sponsored program of Meteorological, Climatological, and Geophysical Agency. School of Meteorology, Climatology, and Geophysics trains senior high school graduates to become high-detected analysts to improve the quality of services in meteorology, climatology, and geophysics. Academy of Meteorology and Geophysics, or AMG, was established in 1955 at Bandung Institute of Technology, or ITB, which then moved to Jakarta 1960. AMG became Education and Training Center for Meteorology and Geophysics in 1978 under organizational structure of Education and Training Agency in Ministry of Transportation. Later on in 2000, Meteorology and Geophysics, and its campus moved to Perhubungan 1 Street of Pondok Betung, Bintaro, South Tangerang. In 2004, AMG was under organizational structure of Meteorological and Geophysical Agency, or BMK, as a governmental agency. In 2008, BMKG, but the organization and management of AMG remained unchanged. In 2014, AMG officially became STMKG, or School of Meteorology, Climatology, and Geophysics. STMKG held higher education in meteorology,
determined by the quality of human resources. STMKG is to create the cadets to have the reliable, competitive, and value-through education and training human resources in the fields of meteorology, climatology, geophysics, and instrumentation. Mission of School of Meteorology, Climatology, and Geophysics are: first, preparing cadets to become member society of meteorology and geophysics, climatology, geophysics, and instrumentation. Second, spread knowledge in the field of meteorology, climatology, geophysics, and instrumentation seeking to improve the implementation of public welfare and enrich the national culture. The third, carry out research that aims to develop the application of science in the field of meteorology.
Within 8 semesters or 4 years. Meteorology is a branch of science that studies the maritime meteorology and meteorology for public services. Climatology is a branch of science that studies long-term weather conditions, or often meteorologies, which has global conception. Geophysics is a branch of science that studies about the physical processes that occur on Earth. The Department of Geophysics generates reliable data in studying earthquake, earth magnets, air electricity is required to observe elements of geophysics, geophysical processing, and analysis, and also skilled in the practice of geophysical instruments. Instrumentation is a branch of science that studies on equipment or instrument used by BMKG departments, cadets measuring and maintenance to the meteorological, air quality, and geophysical equipment, and also maintains communication network and computers. To support the teaching and learning activities, STMKG has several facilities including laboratory.
Thank you for your patience. Ladies and gentlemen, I would like to welcome Professor Bambang Permadi Sumantri Brojonegoro PhD, the Minister of Research and Technology, to the ceremony. Welcome, Professor Bambang Brojonegoro. Ladies and gentlemen, by the Minister of Research and Technology, Professor Bambang Permadi Sumantri Brojonegoro, PhD. Ladies and gentlemen, please welcome Professor Bambang Brojonegoro.
Okay.
Professor
Thank
Bambang
you.
Brojonegoro.
Thank you, Miss Moderator. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, for participants of the webinar, the chairwoman of BMKG, National Meteorology, Climatology Agency, and also distinguished speakers, participants, ladies and gentlemen. First of all, I would like to thank for the invitation from BMKG to participate in the International Conference of Tropical Meteorology and Atmospheric Science. In this occasion, let me share with you our research direction, especially in the area of atmospheric science. So if we move to the next page, the importance of research in general, previous page, please. Yeah. The importance of research in general now becomes much more important than ever, since we are not now just in pandemic, but of course, Indonesia in general would like to elevate our economy from middle-income economy to high-income economy, or to get out of middle-income trap. And in order to get out of middle-income trap, we need to shift our economic paradigm from resource-driven economy to innovation-driven economy. And as you know very well, the good innovation has to be derived from strong research and development, including research in atmospheric science. And in order to promote the innovation itself, and in order to support the ecosystem for research and innovation, the government of Indonesia always keeps promoting the triple helix approach, in which government, academia, and industry working together hand in hand in order to solve the problem and to introduce the innovation. Now, for private sector, for example, we already have the special fiscal incentive, tax incentive, in terms of 300% tax deduction for any private sector or state-owned enterprise that will invest in the R&D. And of course, we keep promoting the interaction and collaboration synergy between academia and industry. We always believe strong collaboration between academia and industry will be the key for successful innovation. However, we know that we have the limitation to promote innovation. That's why we have to have the focus. And one of the way we are focusing our innovation, research and innovation activities is by defining the national research priority. And in the national research priority, there are a lot of areas, one of them related to disaster mitigation. And in the area of disaster mitigation, there is a component of atmospheric science. If we move to the next page, the way we promote higher quality of research in atmospheric science, of course, similar with the way we promote the research in other areas in general. And we understand Indonesia, of course, is not in the forefront when we are talking about high level of research activity, high level research and innovation activity. That's why international collaboration, international cooperation always being our priority in order to improve our research capacity and capability. Another one of the type of collaboration is through G2G agreement or G2G cooperation, government to government, in terms of bilateral, for example, with UK, with Netherlands, with France, and also in terms of multilateral. And of course, Indonesia is member of ASEAN, in which we have the ASEAN collaboration for research activities, aside from other multilateral organizations, including in Asia and in other parts of the world. So the type of this collaboration, of course, has to be fully supported by the government. But government is not the real researcher itself. That's why we always promote direct collaboration between research agencies, universities in Indonesia with their counterpart overseas. And when we are talking about international collaboration in general, of course, we are aiming for output with the high quality. What kind of output? We are looking for the output like the prototype, model or design, intellectual property right, of course, scientific publication, Q1, and then policy brief, as well as monumental artwork. But of course, any international collaboration has to be based by agreement, formal agreement, MOU, technical agreement, agreement on intellectual property right, agreement on material transfer, and of course, at the end of the day, there has to be in-cash or in-kind contribution, as well as fair and equitable benefit sharing. And in order to promote the direct collaboration between universities or research agencies in Indonesia with their counterpart abroad, in the process now, we are in the stages in finalizing, for example, the direct research collaboration between some reputable global universities like MIT with a consortium of universities in Indonesia led by Bandung Institute of Technology, with UK under the brand or under the umbrella of UKSIS, one of them including Oxford University, aside from Coventry, Nottingham, as well as Warwick University. And also with Melbourne University in Australia, with consortium of universities in Indonesia led by University of Indonesia. And of course, there will be more later coming for this kind of collaboration. And government of Indonesia, through our ministry, give the support for this kind of direct collaboration. And of course, we hope that in their collaboration, because they will cover so many areas of research, then atmospheric science hopefully could be the one that will be involved in this research collaboration. In Indonesia, atmospheric research has been conducted by several agencies or parties. Of course, universities will be involved for education and research, while some NGO will be involved related to environmental and disaster issues, as well as, of course, my colleague, Ministry Planning, National Development, about the support for the research in atmospheric science. And then some agencies, government agencies like BPPT, doing assessment and implementation of technology, including weather modification. And then Indonesian Institute of Science, or LIPI, doing research on paleoclimate, as well as Indonesian Nuclear Agency, or BATAN, doing monitoring of suspended particulate matter. And then our ministry, of course, has to conduct the research policy in general, doing coordination for promoting research and innovation. And of course, the host of the event, the BMKG, doing operational and research agency for meteorology, climatology, and of course, air quality. And the research institution under our coordination, Indonesian Aerospace Agency, doing administration, research, and development in the field of space and aeronautics, including remote sensing and atmospheric research. So there are several parties, several institutions involved in atmospheric research in Indonesia. And of course, we hope that between them, or each one of them, doing collaboration, and then of course, they need to provide, of course, the best output possible for improving the atmospheric research in Indonesia. Let me share with you some current activities related to atmospheric research and application. In a disaster sensing remote system, LAPAN, for example, developed SADEWA, which is Satellite Disaster Early Warning System, that provides near real-time information on atmospheric condition, especially cloud coverage throughout Indonesia using satellites. So for Indonesia, this model or this system is quite useful for preparing against the potential of flood disaster. In several areas of Indonesia, because of high rain intensity, they are prone to the flood disaster. And Sadewa could help in at least preparing the population, preparing the area against the potential flood disaster. And then there is another one called Kamajaya, provides information on seasonal prediction, so related to agriculture, of course, to avoid potential drought disasters. And then Jatayu basically provides observation and prediction information on atmospheric dynamics in three dimensions to the position and route of aircraft. So it's helpful for air transportation. And then Srikandi provides satellite-based real-time observation information on atmospheric chemical composition, air pollution, and air quality. So it is very relevant to observe environmental condition. And then Sri Rama provides information on long-term climate change projection. So this is more on long-term issue rather than short-term issue. Aside from that, we also have atmospheric research related to smart water management system. Of course, to understand the sustainability and resilience of the system under condition of change that are expected in the future. And of course, this kind of atmospheric science will be potential to contribute to the water management. Aside from that, of course, we have to have spatial observation on climate change. At the end of the day, this is our focus, how to prevent, how to protect our Earth against this climate change. And of course, SDG, Sustainable Development Goals, trying to provide the area to deal with climate change. And of course, research in atmospheric science is part of that. For Indonesian specific purpose, of course, hydrometeorological disaster management will be the key. As you know, as I mentioned earlier, hydrometeorological disaster is one of the potential disasters that could happen in many areas in Indonesia. And not only about the flood, but also about the drought, And then, of course, related also to atmospheric environment and health, because there is a potential of forest fire that happens in Sumatra, in Kalimantan, then recurring every year. And of course, we have to observe the hotspot and we have to do atmospheric science to make sure that we can predict and we can prevent the forest fire at the big scale that could affect even our neighboring countries. So these are the current research going on related to atmospheric research and application. And then there are also ongoing international cooperation in the field of atmospheric research. Some of our partners, for example, with Research Institute for Sustainable Humanosphere in Kyoto University, Japan, and then also with University of East Anglia, Leeds University, and University of Reading, all of them in UK, on the Terra Maris, maritime continent as driver of global climate, as well as with JAXA on synthesis of dynamics and chemistry to understand atmospheric process in tropical tropopause layer, as well as, of course, collaboration between our aerospace agency, LAPAN, with NASA on the launch on ozone sonde from Indonesian side for the first time in 8 years. So they have done that. And of course, it will be useful and contributing to the advancement of atmospheric research. So in general, this is our research direction related to atmospheric science. And I hope this conference not only can give broader aspects and latest findings, latest research on atmospheric science, but also we can find the best way to deal with climate change and of course the best way to prevent the potential disaster, especially hydrometeorological disaster that always occurs in Indonesia, almost every year, sometimes from month to month. So we have to be careful, but in order to prevent ourselves, we need to improve our ability in doing the atmospheric research itself. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Profesor Bambang Permadi Sumantri Brojonegoro, for attending. Ladies and gentlemen, now we are going to have a virtual photo session. Approximately the next 3 minutes. I will start the countdown now. So for the first slide, 1, 2, 3. For slide 2, 1, 2, 3. For slide 3, 1, 2, 3. Slide 4, 1, 2, 3. And for the last slide, 1, 2, 3. Thank you, and you can turn off the video now. Ladies and gentlemen, the next session will be guided by Dr. Andi Eka Sakya as the moderator of the rest of the keynote speech and discussion session. Dr. Andi Eka Sakya is a principal engineer who is currently serving at the Agency for the Assessment and Application of Technology, or BPPT. Previously, Dr. Andi worked as the Executive Secretary of BMKG since 2006 and served as the head of BMKG from 2013 to 2017. Without further ado, I would like to invite Dr. Andi Eka Sakya to lead the next session.
Well, thank you very much, Yesi, and Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Excellency Minister of Research and Technology, Head of BMKG, Head of BPPT, Head of LAPAN, and Head of Department of Coupled Oceans, Atmospheric Science of JAMSTEC, eminent researchers, ladies and gentlemen, dear participants from all over the world. I noticed that at the time being, there have been more than 900 participants from both Zoom and YouTube. Well, again, thank you very much for being with the second international conference of tropical, meteorological, and atmospheric science in this afternoon. We are now welcome at the two keynote speeches. In these sessions, we are pleased to welcome two very special and prominent keynote speakers. The first is Dr. Yoneyama, Director of the Department of Coupled Ocean, Atmospheric, and Land Processes Research at JAMSTEC. And the second is Professor Thomas Jamaluddin, who is the head of Institute of National Aerospace Science. Let me now introduce the first speaker, Dr. Kunio Yoneyama, He is very well known for his initiative on Years of the Maritime Continent, and it is a multi-year field campaign in the largest archipelago on Earth. He will share with us about the suggestions for observations in the maritime continent beyond the Year of Maritime Continent and what we learned through the Year of Maritime Continent Intensive Observations Project. Learning directly from someone who directly prepared and led the project is indeed a luxurious in itself. So without further ado, I ask that you give full attention to Dr. Yoneyama. With that, and help me in welcoming him to the stage. Dr. Konyo Yoneyama. Time is yours.
Terima kasih Bapak Andi. It's my pleasure to make a presentation from now. So from now, I will share my slide. Can you see this, my slide?
Yes.
Yeah. Okay. Selamat sore. Nama saya Kunio Yoneyama. Actually, first of all, I'd like to express my sincere appreciation to the organizing committee, BMKG, under the leadership of Professor Dwiko Karanawati, and STMKG and IPB University under the leadership of Professor Alif Satoyer for hosting this ICTMAS conference under difficult situation. I'd also like to thank Listek Brewing, the leadership of the Professor Bambang Brojonegoro for their support, and the LAPAN under the leadership of Professor Thomas Jamaluddin, and BPPT under the leadership of the Professor Haman Rezer, and many other agencies and universities, as well as international participants, to make this conference happen and active one. This is the second ICTMAS meeting. I think the second has special meaning because it means you could continue this opportunity. This is definitely a good opportunity, especially for young scientists in the maritime continent countries. Is it okay? Besides, the first conference was hosted by LAPAN and ITB. So such alternative of hosting institute is also a good opportunity to learn how to connect with the international community for maritime continent agencies. And also, international community can know about the local agencies and universities. Today, I'm going to talk about the suggestions for observation in maritime continent beyond the Rime Sea. This is meant to tell what we learned through the Rime Sea field campaign. In particular, today, I will introduce some activities in which JAMSEC were involved past 5 years. First, I'd like to emphasize the importance of in-situ measurement, especially for AC interaction. Based on our two-field campaign, conducted near the west coast of Sumatra in 2015 and 17. Then I will show one example as a new tool to measure AC interaction related parameters. Finally, I'd like to point out some key points that I learned or just felt through our very recent field campaign. We call it the CSO 2021. From now, I will show very specific science results. Apart from the another general review or general explanation, please accept this because it may help you to understand what really obtain the new knowledge through these activities. Okay, I believe the many of you know currently we conduct field campaign program called Years of the Maritime Continent since 2017, and it is expected to continue at least until 2022. YMC is designed to improve our knowledge about weather climate systems over the maritime continent and its prediction scale. And it consists of many in-depth observations, focusing on various dominant phenomena over this region, such as dinocycle rain, cold surges, modern oscillation, horizontal intraseasonal oscillation, and so on. As you can see, okay, as you can see, at least the 16 projects have been or will be planned to take place during 5 years. So far, we at JAMSTEC conducted the 2 field campaign in the west coast of Sumatra, including a pilot study in 2015, and other 2 field campaigns were dedicated to study boreal summer intraseasonal oscillation, what we call BCISO, in 2018 and 2020 in the Western Pacific. In addition, very recently, we added a new campaign to study cold surges this January to March. So from now, I will talk about the, I will introduce the some results and also the, I direct emphasize the importance of ASC interactions measurement by using institute tools. As I mentioned, Sumatra campaign were dedicated to study dinocycle rain along the coast. So we deploy the our research vessel Mirai of the coast, and while we deploy land-based site in Sumatra in collaboration with the BMKG and the BPPT. Weather radar successfully captured offshore propagation of diagonally developed convex system as shown in here. Okay. Since our dataset has already been open to the public, anyone can use our data. Indeed, researchers from Meteorological Service of Singapore use our data to evaluate the numerical model. They perform to simulate convex system over Bengaluru using our pilot study data with their own numerical model. Left panel shows mean diurnal cycle of rain at Bengaluru, but it seems you can see the observation and the numerical model product showed consistent in not only in intensity but also the peak time. However, they noticed that our issue measurement, sea-surface temperature measurement taken by our pen showed higher than Liana's product by 1 degree Celsius or more. So they adopt in-situ sea-surface temperature measurement into their model. Then the model must improve like this one. It means that the exact sea-surface temperature information is very important to simulate the dinocycle rain. Actually, we also notice such temperature differences among analysis products. Here, monthly sea surface temperature product for December 2017, you can see it's completely different each other. If we compare such satellite-based data or numerical model output with our CTD observation data obtained by our research-based MIRAI, we can confirm the our GMPE seems to be good, but others is not so good. Anyway, these results suggest precise sea surface temperature course is very crucial to simulate local convective system. It means that we need reliable issue data. So from next slide, I will show a candidate for this need. This need means that we need exact precise sea surface temperature data, institute data, based on the other field campaign. We conducted a field campaign focusing on the boreal summer monsoon 2 times in 2018 and 2020, just last year. In both campaigns, we deployed unmanned autonomous surface vehicle called Wave Rider. From now, I will tell the result obtained by this Wave Rider. Actually, when we conducted the BSM 2018, we did various kinds of observation at several locations, including Indonesia. For example, we launched the special radar sound 3 sites in Vietnam and Indonesia, and also we conducted observation in the Philippines and as well as the Palau Islands. At the time, we deployed 3 wave gliders from Palau. Today, I will talk about this wave glider observation. And this slide tells the motivation of our wave glider observations. Previous studies show the relationship between the convection onset and sea surface temperature Laplacian. Namely, convection onset is not proportional to sea surface temperature. Rather, rainfall event prefer to occur around 29.5 degrees Celsius, and sea surface temperature Laplacian is negative. You can see it here. Namely, sea surface temperature gradient should be a key to understand the convective onset. However, usually we use the satellite data, but our satellite-based data sometimes fail to capture the correct sea surface temperature, especially under the deep cloud condition. In addition, we often use satellite-based IR data as index of rainfall, but it's sometimes IR peak and rainfall region do not correspond. You can see like this one, okay? Thus, we need an instrument measurement tool that can measure sea surface temperature regardless of the cloud conditions. In 2018, we could not get a SIP time. Instead, we can deploy a wave glider from Palau. As can be found from its name, wave glider, this autonomous vehicle can convert wave motion into propulsion. In addition, we can attach several instruments in addition to their standard measurement system. Those are surface meteorology, surface ocean temperature and salinity, even ADCP, current measures. In addition, this time we attached GNS Global Navigation Satellite System receiver to derive precipitated water vapor that can be used as an index related to the atmospheric convection. Okay. Yes, time series of sea surface temperature obtained by wave gliders. If they capture well, You can see this one. And when we compare to the satellite data, at least the same quality or better than this one. And the big advantages for observation by web radar is we can obtain very high temporal resolution every 10 minutes or so. However, at that time, we failed to measure some key surface meteorological parameters. You can see sometimes, for example, we do not get a relative humidity like this one. Only for the first 1 week or so. After that, it's gone. And so I need to imagine the situation using surface temperature and salinity data. However, this time, as I mentioned, we attached a GNS receiver to derive the crystal water vapor. To evaluate GNS-derived water vapor data reliability, we compare them with that derived from latest data when the web grader was located near Palo Island. We compare them with the water vapor based on the GPS or latest sound. You can see good correspondence. We also compare to the such a GNS-based
Ini punya saya kan begitu.
water vapor.
Tapi sekarang juga diratakan.
Some noises is coming. Okay. Okay. Also, they show the same quality, at least the same quality during in the fine day with satellite bait. It means that we can obtain a GNS-based water vapor. As I mentioned again, the big advantages we can obtain such water vapor data for every 10 minutes. It is completely different from the other satellite base. You can see when we compare to the using this data set, for example, we can study the impact of the cold pools that are associated with the atmospheric convection. I'm sorry, I will skip this one to save time. And also, in the last year, we could get a save time and we could conduct the similar observation. We can deploy our research-based MIRAI and also deploy the web gliders as well as voice system. At that time, our web radar could correctly capture the sea surface conditions. For example, if we look at the if the temperature abruptly drops down and the humidity increased and sea salinity decreased drastically, at that time rain occurred. By combining the MIRAI radar, we can confirm surely at that time the cloud system passed over the web radar system. In addition, we can also notice the some abrupt change with wind. At that time, by comparing to the MIRAI radar Doppler wind, we can confirm at that time surely convex system changed. It means that the web grader can, this web grader can correctly measure the sea surface condition very well. So this time we have a radar system, but even without a radar system, based on this data set, we can expect, oh, something happened over this region. It means that with that set, we can conduct some observation. It means that until now, I explained what we did, and I intend to emphasize the importance of AS interaction study. And recent technology using web radar is one of possible tools to measure necessary parameters. From now, I will briefly mention about our very recent field campaign called Cold Surge Observation 2021. Okay. Actually, when we designed the YMC BSM 2020, we wanted to investigate the impact of the convection below of the northern coast of the island. And as a part of the dynamic cycle, then onto the system over the BSM 2020 main observation area around the Mirai. This is because based on the previous study, we noticed such a relationship with each other. Thus, to study the relationship to the local dynamic cycle, we intended to conduct 8 times per day latest observations at Biak Island. So my colleagues, BMKG colleagues, made a site survey for that. However, due to the COVID-19 pandemic, we had to cancel our visit and this enhanced observations. But since we've already purchased the over 200 latest transmitters, we decided to use such a latest fund for another research purposes called search. For this purpose, we changed the site and strategy. Today, I will not talk about this much because the Saturday, my colleague, Kostak Moteki, will make a presentation about this one. So instead, here I'd like to mention about the, although we at Jamstead planned this, but this campaign itself was completely conducted by BMKG alone. So I'd like to mention about the how and what I felt through this campaign. As a background, we should change the scientific target, observation site, and the schedule and the personal law. We could conduct this observation because we use well-established BMKG observation network. And the BMKG and Jamstack often interact based on IA, and we know each other very well. And also, most important thing that we had field campaign experience. So if we ask to BMKG to conduct this observation, BMKG currents easily understand what we want to do. And before and during the campaign, we exchange ideas through CNS, SNS, web meeting, and email, and so on, so that anytime we check the current status. In addition, we have shared the same knowledge through the past campaign. For example, BMKG staff recognize the importance of data quality control. So when we decided to conduct this observation, BMKG can be aware of such a data quality. So it makes it very easy to discuss key points. Besides this time, we request only latest observation on the GNS receiver deployment. So we can easily conduct. So such a concise measurement system is very key. Based on this point, I'd like to mention about the possible future observation style, even under the difficult situation. Actually, most of OMC observation are originally planned by international community. Of course, Indonesian and other maritime continent country scientists are involved in this community. But I'd like to request that the next field campaign should be proposed and led by the maritime continent scientists. Of course, non-maritime continent country scientists will join its discussion and can also, for example, provide some tools. But if it happens, I think that there are many advantages, not only for the maritime continent country, but also for international community. Such a plan should fit the local needs. For example, I know it's very difficult to obtain research permit when we want to operate the unmanned autonomous surface vehicle, but local scientists can do. Besides, even we start observation as a temporary one, it can be expanded to long-term observation if it fits to local demand or needs. For example, we add, as I mentioned, I'm sorry, I didn't mention, but we added the GNS receiver for CSO 2021. Right panel shows time series of the temperature and precipitated water vapor. As many of you remember, it was very sadness that Sriwijaya aircraft crashed. I'd like to express my deepest condolences to all Indonesian people. But here I want to say we deployed the GNS receiver. Such a data captured abrupt increase of moisture at the time. Of course, it might not be related to the crash. However, at least such information is helpful to know the atmospheric condition at the time. Our data should be used not only for science, but also for social needs. Fortunately, weather and climate study without any special notification that can contribute to the social needs. So such a data can be used for immediately many purposes. So the time has come, so I will skip to read this key point of concluding remarks. But I'd like to, at least I'd like to mention that so far we are conducting observation and we obtained many good results. And at least we confirm the each measurement very useful. And I suggest the, for example, the web radar is one of the new tools to study interaction effectively and nicely. But I strongly recommend the next campaign should be led by the maritime content scientists. At that time, the most important thing is the communication among maritime content country and non-maritime content countries. Well, yeah, of course, this ICTMAS meeting is a good opportunity to know each other, to exchange related information and knowledge. So I'd like to emphasize that let's enjoy this ICTMAS meeting. Thank you. Thanks so much.
Thank you. Thank you very much, arigatou gozaimasu, Dr. Yoneyama. I underlined the importance of direct observations and how vital the result is to improve the modeling, as well as you showed how satellite data do not capture SST and rainfall event correctly for some cases. It appears that collaborations is becoming a new mantra for research in the future, especially facing the unavoidable climate change and global warming. If you were becoming researchers living in Indonesia and realizing how big the threat is, so what do you suggest for us to do most, Dr. Yoneyama?
Thank you for summarizing my talk, and also this is a good question. Because you know, as I mentioned, that discussion is more important thing. Because so far today I showed only some example, and at this moment, one of the key point of the YMC or such issue is the reason why I showed today web radar is the ANC interaction, because completely different from other areas. So I emphasize the because the ANC interaction as well as the land air sea interaction. In such cases, only such a field campaign or maritime content scientists can obtain such a knowledge or data. So if you think about the next step or observation, please consider about the singularity of these areas.
Yeah.
So such an interaction should be a key. And one of the reasons such a unmanned vehicle is very useful, even under the pandemic situation. I'm sorry if I may misunderstood your question, but at least you already summarized my talk and you share the key point to the others. So
yeah. Thank you very much. So again, on behalf of the committee, I would like to thank you for your very excellent presentations and arigatou gozaimasu. And let us now give a big applause to the director of the Department of Coupled Ocean Atmospheric Land Process Research, Dr. Keynote Yoneyama. Thank you very much.
Terima kasih.
Dear participants and ladies and gentlemen, now let us enjoy the second speaker, Professor Thomas Jamaluddin. Professor Jamaluddin is the head of the Institute for National Aerospace Science, LAPAN, since 2014. Although by educational background, he is an astronomer, but he was the head of climate and science utilizations before being appointed as the head of the institute. Since then, his expertise is broadened and covering atmospheric science and remote sensing. And it would be worth hearing him talking about the readiness and how the agency and institute has developed a lot of tools in laying the foundations to support the atmospheric research, and even the Minister, Excellency Minister of Research and Science and Technology has also covering his talk about that. So with that, and without further ado, let us now welcome Head of the National Space Research Agency to the stage, Professor Dr. Thomas Damaludin. Time is yours.
Thank you, Mr. Chair, Dr. Andika Sakya, Honorable Head of BMKG, Professor Dwi Korita, and Keynote Speaker, Dr. Kunio Yoniyama, and also the colleagues, participants of this conference. I'd like to share my presentation. I'd like to speak developing aerospace science and technology related to tropical meteorology. First, I'd like to discuss concerning developing atmospheric science. As Research Institute, LAPAN has been asked by the Ministry of Research and Technology that time, Professor Habibi, since 1990s, to develop the climate modeling or the atmospheric modeling. And since then, we developed several type of the modeling. First is SADEWA, satellite-based desert early warning system. And then we also the observational tools, Santanu, this the rain radar for detecting the extreme rain, and Kamajaya, this concerning the midterm prediction, and Sri Rama, this long-term prediction, and Sri Kandi related to atmospheric composition, and Gatot Kaca related to the GNSS-based profile of the temperature based on the radio occultation. So as also mentioned by the Ministry of Research and Technology, SADEWA is one of the research in innovation product of LAPAN. This is the example of the early warning from the SADEWA, the prediction of the extreme condition that made the big flood in Jakarta in early 2020. And Santanu is the rain radar based on the ship radar, and this has been installed in several locations. And Kamajaya, this is the system for prediction of the early rainy season or the dry season. This is the example of the analysis of the Kamajaya to predict about 6 months ahead. And Sri Rama is this long-term prediction system. This for 1 year up to several years ahead. This is the example of the Sri Rama prediction that the possibility of the normal dry season in 2021. And Sri Kandi, this give information concerning the atmospheric composition. and Gatot Kaca. This the system based on the radio occultation to provide data concerning the profile, the atmospheric profile over Indonesia. And also, as mentioned before by head of the BMKG and also by Dr. Yoneyama, that there is the Teramaris program as the maritime continent as the driver for the global climate. This campaign will be done next December until February 2022. This under the collaboration from several institutions. And during this Teramaris project, there is the surface observation and aircraft observation. Mainly will be done in southern part of the interaction of the ocean and the coast area. This will be observed using the radar and also aircraft and some other facility. And the objective of this Teramaris is to observe convective dynamical atmospheric system of our maritime continent, quantify interaction within the diurnal cycle, model our maritime content convective system in hierarchy of models, and deliver observation and process understanding for other program. And this the flowchart of this Teramaris with the some participant and also the International Year of Maritime Continent project. And in Indonesia, this Teramaris project also related to some work breakdown structure in the research collaboration concerning the diurnal convection mechanism and also the diurnal convection cycle experiment and also some project on development of the atmospheric observation. And LAPAN during this the Teramaris project contribute on observational campaign using the transportable radar and radio zone for southern part of the West Java, and numerical weather prediction experiment, validation, data simulation, and physical parameterization scheme selection, and also research on diurnal cycle convection, ocean atmosphere interaction, and multi-scale interaction. And for studying the atmospheric science, LAPAN also design of National Flying Laboratory for atmospheric observation. This in our plan. We will use the N219 aircraft. This the new type of the aircraft. This produced from the collaboration LAPAN and PTDI, the aircraft industry. And also we have also another aircraft that is LAPAN surveillance aircraft or LSA. Maybe one of these aircraft will be used for the air laboratory, and this the preliminary plan for some instrument installed in the aircraft to make the airborne laboratory of space or the atmospheric sciences. And the other program in LAPAN is developing micro satellite. Some of this program related also with the tropical meteorology. Since early 2000, LAPAN developing micro satellite started with the LAPAN A1, launched in 2007. And then in 2015 and 2016, we launched LAPAN A2 and LAPAN A3. LAPAN A3 is the collaboration LAPAN and IPB. So it's called the LISAT LAPAN IPB satellite. And now we are preparing the fourth microsatellite 8A4, mainly for observation maritime. And then after that, we are planning for launching the low orbit communication satellite consisting of 9 satellites. Hopefully this will be finished by 2024. This is the example of the result from the 8A2. This from the land cover monitoring and also some environment monitoring. And the 8A3 result, this mainly observing the analysis for the vegetation monitoring, this collaboration with the IPB University related to forest, plantation, and also paddy field. And now we are preparing the 8A4 with the mission mainly on the Earth observation using the optical and thermal infrared sensors and monitoring global maritime traffic using the automatic identification system, and also the scientific mission for the space science mission using the magnetometer. And this the some information related the camera that will be used in the 8A4, medium resolution multispectral camera and high resolution multispectral camera. Also, there is the ICE automatic identification system for monitoring the movement of the ship. And also there's the experiment related to Earth magnetometer and also the sensor, bolometer sensor. This in collaboration with Hokkaido University and BBBT. And this the example of 8 line imager space application. And also the medium resolution imager. This mainly for observing Earth observation. And also infrared camera, this for detecting some environment or the Earth observation related to this the urban area, also the oil spill monitoring and land cover and land use monitoring. And this the other planning of using the long wave infrared sensor. This in collaboration with BBPT and Hokkaido University. And you're also preparing the satellite constellation, the low orbit satellite constellation for communication. We hope this system, this can facilitate for the disaster mitigation system. Then we use to facilitate with the low orbit communication satellite. Hopefully we can launch 9 satellites during these 5 years. And the other one is the utilization of remote sensing technology. We have several ground stations in Parepare and Rumpin. This cover all of Indonesia. And we use this data and collect this data using the data center in Jakarta and also the data center in Parepare. And we collect several types of the resolution, the higher resolution images from Pleiades, and this resolution about 50 centimeter, and high resolution using the spot 6 and 7 with the resolution 1.5 meter, and medium resolution 15 to 30 meter using Landsat 7 and 8, and also low resolution. This mini satellite collected this Terra Aqua and SNPP, NOAA, METOP, and Himawari. This mainly for observing or monitoring the environment, and also including the weather. And also there is the SAR, the for radar remote sensing using TerraSAR and Tandem X. And this is the example of the images we collected. Also for high resolution, we collected also Bigbird, bird view, and also GeoEye and Alas Pulsar. And use this remote sensing data for drought and forest fire monitoring. We developed some analysis method using the greenness information from the remote sensing data, and also the combining with the Himawari, the weather satellite information, this to give the information related to standard precipitation index information and other parameters. This from the greenness level of vegetation, we analyze the drought during the dry season in Indonesia. And also we use the monthly accumulated rainfall in Indonesia. This also related to drought analysis, and also the precipitation index over Indonesia. And we also analyze the forest fire danger rating. We use the data from several sources: temperature, relative humidity, wind speed, rainfall, and also the other parameter to give the information concerning the fuel moisture codes. This the data that we use, the Himawari, is for the precipitation information, and also temperature, relative humidity, and wind speed. We use the data from the SADEWA, satellite-based disaster early warning system, and based on this data, we give information concerning the forest fire danger. We give the FFMC, this potential level or relative is ignition related to the forest fire, and also the for the potential drought and haze, and also the for fire control difficulty, and also the fire weather index. We provide all of this data in our website. So this the for early warning system for the forest fire danger. This for the same this March, and give the FFMC, and also this also put some information related to the hotspot. And use the remote sensing data for forest fire early warning system. Before forest fire, we give early warning system based on the forest fire information early warning system. This the forest danger. The forest fire rating system, and also during forest fire, also give the information related to the hotspot. We provide the information on hotspot in our website and also in the Android application. And also we make the haze monitoring during the forest fire event. And after we also build map to analyze the impact of the forest fire. This is the information of the forest fire. We provide the daily data for fire. We also provide in the Android application the Lapan Forest hotspot. This can be downloaded using Play Store, and the application has been used by many local governments to anticipate the fire. Thank you.
Well, thank you very much, Professor Thomas Jamaluddin. And before closing these keynote sessions, but I would like to use this very vital sessions to ask you a very small, very short questions. Learning from so many tools that have been developed under your leadership, especially based on weather and climate modeling, as well as utilizing most the remote sensing observed data. So in line with the trend of collaborative research and realizing the cry out of many researchers on remote sensing based measured data, will your agency, institute, will expand your facility and measured data to be accessible for researchers from other than your institute? Maybe you can just comment on that.
Yes, of course. We can share our data, and hopefully under the Ministry of Technology and the Research and Innovation, National Research and Innovation Agency, we can share the facility as the national facility for research and innovation on the atmospheric sciences.
Oh, well, thank you very much. Again, on behalf of the committee, I would like to thank for your marvelous and very comprehensive research for speech. And let us now give a big appreciations to the head of National Space Research Institute, Professor Dr. Thomas Jamaluddin. Dear participants, with that, I will resume the keynote session and deliver back to Yesi. Yesi, back to you.
Thank you, Dr. Andi Ekasakya, for leading such a wonderful and interesting discussion. And we would also like to thank our keynote speakers for sharing their insights about the atmospheric science research in tropical region, especially Indonesia. Ladies and gentlemen, we have now reached the end of our opening ceremony. I would like to thank exceptional speaker and distinguished participants for gracing the ceremony with your presence. I would also like to apologize on behalf of the organizing committee for any inconvenience during the ceremony. Please note that the conference will still be held for the next 2 days. So on the second day, the session will start from 12:45 until 17:30. And on the third day, the session will start from 7:45 to 12:50 Jakarta time. Ladies and gentlemen, I hereby end my duty as the MC of the opening ceremony, and I wish you a great time during this conference. Thank you, and see you tomorrow.
Thank you.
Thank you very much.
largest maritime country in the world, we are aware of the importance of our ocean in influencing the world's weather and climate, especially the influence of the Indonesia through flow connected between the Indian and Pacific Ocean to the weather and climate states in the world. Indonesia, through the Agency for Meteorology, Climatology and Geophysics, BMKG, is strongly committed to contribute to the safety of human activities and community welfare by continuously educating people on the importance of ocean weather climate literacy and sustaining our observation and keep strengthening our provision of the accurate maritime weather and climate information, as well as early warning of the coastal disaster information such as storm surge, tsunami, and sea level rise to the community in Indonesia and in the region. Meteorological Day of 2021. Let's strengthen our partnership for the better ocean weather climate information.
Indonesia merupakan negara kepulauan yang berada di garis khatulistiwa, terletak di antara 3 lempeng aktif, 2 benua, dan 2 samudra, sehingga menjadikan Indonesia sebagai negara maritim dan agraris. Tidak hanya memberi keindahan, Indonesia kaya akan sumber daya alam yang memberi kesejahteraan kepada masyarakat luas. Namun di balik keindahan itu tersimpan potensi bencana. Kondisi alam itulah yang menjadikan peran BMKG sangat penting. Penduduk yang padat, pembangunan infrastruktur, perkembangan industri, dan tingginya penggunaan alat transportasi sangat berkontribusi terhadap cuaca, iklim, dan kualitas udara. BMKG merupakan lembaga resmi yang menangani masalah cuaca, iklim, kualitas udara, gempa bumi, dan tsunami. Sehingga BMKG sangat erat kaitannya dengan keseharian kehidupan masyarakat di Indonesia. BMKG memiliki 186 unit pelaksana teknis pengamatan yang tersebar di seluruh Nusantara. Kami senantiasa memberikan informasi cuaca untuk penerbangan, maritim, dan pariwisata. Informasi iklim untuk pertanian dan ketahanan pangan. Informasi kualitas udara untuk mengantisipasi perubahan iklim. Informasi gempa bumi dan tsunami, serta informasi terkait hilal dan penanda perubahan waktu. BMKG senantiasa menyajikan informasi secara rutin terkait cuaca, iklim, kualitas udara, gempa bumi, dan tsunami. BMKG memiliki stasiun pengamatan meteorologi, klimatologi, geofisika, dan Global Atmosphere Watch yang tersebar di seluruh Nusantara. BMKG memiliki 120 stasiun meteorologi yang berguna untuk mendata darat. Stasiun meteorologi mengambil dari taman alat dan radar cuaca. Data tersebut lalu diolah sehingga menghasilkan produk layanan informasi prediksi cuaca yang bermanfaat untuk kelancaran transportasi, pertambangan, pariwisata, olahraga, dan kesehatan. BMKG memiliki 27 stasiun klimatologi. Cuaca dalam jangka waktu tertentu. BMKG memiliki 31 stasiun geofisika. Setiap harinya stasiun geofisika mengambil data dan diolah sehingga menghasilkan sistem peringatan dini gempa bumi dan sistem peringatan dini tsunami. BMKG memiliki 3 stasiun pemantau atmosfer atau Global Atmosphere Sorong, Papua Barat. Global Atmosphere Watch bertujuan untuk mengawasi efek emisi gas rumah kaca dan parameter yang berada di atmosfer bumi.